Okay, here we go. We have the objectives of this lesson. Is by the end of this lesson, you should be able to name points, lines, and planes correctly, name segments and rays, sketch intersections of lines and planes, and solve real-life problems involving lines and planes. Vocabulary words to study are listed below. Feel free to pause, rewind, copy down these in your notebooks, and let's go over the definitions of them. Okay, in geometry, the undefined terms are points, lines, and planes. Point, lines, and planes together with set are the undefined terms that provide the starting place for geometry. When we define words, we ordinarily use simpler words, and these simpler words are in turn defined using yet simpler words, right? This process must eventually terminate at some point. The definition must use a word whose meaning is accepted as intuitively clear, because that meaning is accepted without definition. We refer to these words as undefined terms. These terms will be used in defining other terms, although these terms are not formally defined. A brief intuitive discussion is needed. So we will be discussing them. And then the defined terms are segments and rays. And you need to know that, so take note of this. Okay, so let's look at a point. A point indicates a location. A location. A location. That's all it does. It indicates a position, a location. A point has no size. It has no size. It has no size. That means no length, no width, no height. Okay? It is named by a capital letter. So it's named by a capital letter represented by a dot. It's represented by a dot. If you look at a picture of a point, we usually draw a dot. But what it represents really, it is a location. And notice we put a capital letter right by it. So when you're naming a point, you have to name it with a capital letter. Remember that. Not a lowercase letter. It has to be a capital letter. Also, a point has no dimension. It has no dimension. Okay? It has no dimension. Okay, a line is represented by a straight path that extends in two opposite directions without end and has no thickness. A line contains infinitely many points. It contains infinitely many points. Okay, so that's what you're going to write here. Infinitely many points. Okay, a line has one dimension. Okay, it is named by a lowercase letter. Like, for example, look at this line right here. Notice this lowercase letter. It's idolized. Okay, in this case, we could name this line L. So we could name it like that, line L. That's one way to name this line. However, it could also be named by two capital letters with a double arrow on top. For example, like this, line AB, or doesn't matter, it could be any 2 points on the line, or line BA. As long as, doesn't matter the order, as long as it has the two capital letters denoting those 2 points, so it's denoted line AB or line BA, we're naming the same line. This one could be also named line L, that small letter that is just naming the line. Also remember, since we can name the line by 2 points on the line, a line has to contain at least 2 points. So it has to contain, I'm going to put it here, it has to contain at least, that's important, at least 2 points. Okay, and that is important because the line is denoted by 2 points. Okay, through any 2 points, there is exactly one line. That is a postulate, and we're going to learn what that is later. And then we have the plane, and the plane is represented by a flat surface that extends without end and has no thickness. A plane contains infinitely many points. Those points extend in all directions within the flat surface. Okay, so remember, it extends in all directions but within the flat surface. These planes, it's two-dimensional. Planes are two-dimensional, or they have two dimensions, right? Planes are two-dimensional. So you could go in any direction in that flat surface, okay? Now, how do we name planes? Well, we name it by that capital script letter that it's on a corner somewhere representing a plane. Remember, we draw a plane like a parallelogram, but remember the plane does not have an ending, so it does not end. It keeps going forever and ever and ever. So don't think that the plane ends there, because you gotta think that it's gonna go through space in this flat surface, going through space, and has no end, so it doesn't end there. Okay, now notice we drew here 4 different points E, S, C, and Y. Well, we could name the plane by just that capital script letter, which we could say, well, that's plane R. Or we could also name it by 3 points on the plane that are not on the same line, that are non-collinear. Not on the same line, non-collinear. You write that down, non-collinear, which means they're not on the same line. So for example, I could name this plane YES, plane YES. There you go, plane YES. Or planes CSE, or plane CSE, and those could be names for that plane. Okay, or any 3 points, it doesn't matter the order, as long as those points are non-collinear, you could name that plane by those 3 points. Okay, since we're talking about non-collinear, well, we have to ask ourselves, what are collinear points? Collinear points are points that obviously there are on the same line. If those points like R, E, Y, S, notice there are on line RE or line RY, because you could name the line by any 2 points. Remember that. So points that are on the same lines, those are points collinear. Collinear. Notice that the word says co, meaning cooperation, and line, see, line. So I am going to the root of the word co-line so that you remember. So cooperate on the same line, or they are in the same line together, together in the same line. Okay, coplanar, well, they are in the same planes. These are points and lines that are in the same plane. Okay, like all these points, all these lines right here, they're on plane C. Okay, here is C, capital letter, on a corner there. There is no point by it, so we can name this plane right here plane C. All right. Okay, then we have space, and space is basically the set of all possible points. The set of all possible points, and that would be 3-dimensional, right? All possible points. Remember, this is 3-dimensional. Okay, here's an example. Here we are given a plane. We're given points that are on the plane. We have a line on the plane, and we have a line that comes from top, that is not on that plane, comes from top. It intersects the plane at this point right here, and then keeps going down. You see that? So it goes right under. So this line M, is not on that plane. So let's look at the questions. What are the 2 other ways to name line QT? Line QT. Well, notice line QT is the line that is not on the plane. So line QT could be named by line TQ. We just could invert the letters, TQ, right? Also, we could name that as line Q, and notice there is another point on that line, QN. Line QN. And there are more ways to name this line, like for example, by this letter right here, line M. So they asked for 2, I gave you 3. Okay, and there are more ways because you could switch the letters any way you want. And then he says, what are 2 other ways to name plane P? Well, plane P, which is this plane, the yellow plane right here, the yellow flat surface, we could name it by plane P or any 3 non-collinear points, points that are not on the same line. In other words, we cannot name this plane RQS or RSQ because these points are on the same line. We cannot name this plane with point T because point T is not on that plane, or point N is not on that plane. It has to be points that are right on the plane. So any of the points that are on the plane that are not non-collinear, those are the points that we have to use. For example, in this one, plane P can be named plane, and I look for RQV. Plane RQV. That's one way to name it. I could also name it QSV. QSV. Or plane QSV. And notice it doesn't matter the order. You could name it VSQ or VSR or however, any 3 points that are not on the same line, name that plane, okay? It says name 3 collinear points. We already have the 3 collinear points. It could be points R, Q, and S, or it could be points T, Q, and N. In other words, when we're naming points, I'm going to name points. Points. And notice I am going to separate them by a comma. So points T, comma, Q, comma, and N. Those points are collinear. Points T, Q, and N. Those points are collinear. Also, points R, Q, and S are also collinear. Okay, name a point not coplanar with points R, S, and V. So I'm looking for points R, S, and V, which we could name the plane by those 3 points. So it's asking for a point that is not non-coplanar or not coplanar. Well, that would be point T. See, T or point N is outside that plane. So I would say point T. That's one of them, okay? Okay, let's take a look at this figure. Point lines and planes. Oh my God, point lines and planes. I'm just gonna name the ones that are shown, okay? It says points. I have point I, point T, point H, point S, and those are drawn. There are many more points. Like here's a point here, but it's not drawn, so I'm not gonna name it. I'm gonna name point I, points I, and I put a comma, point H, point T, or point S, and that's that. Lines. What are the lines? What are 2 lines drawn here that they're showing? So we could name lines by 2 points on the line. So I'm gonna say line. Remember, it has to be capital letters. TI or IT. There we go. And another line would be line HS. Line HS. I'm gonna draw it right here. Line HS. Notice how I denote with a double arrow on top of the 2 letters or the 2 points that I'm using to name the lines. And then we have the planes. Planes has to be either 3 non-collinear points or remembered by this letter. So we have this big plane right here. I'm gonna name that plane C, or it's named plane C. I'm naming this one right here, the one that is the long one, right? It doesn't matter. I'm looking at it as the long one, but remember, planes have no end, so this flat surface will go on forever. So they're all the same size in reality, even though in here we cut them and we put edges on them. Planes do not have edges, so do not imagine planes as having an end. Then we have plane O, and then plane R. Okay, and that concludes this one, right? This example. Then we have the defined terms of geometry. The defined terms of geometry, so we have a segment, which is part of a line that consists of two endpoints and all the points between them. That means two endpoints, that's usually is a beginning and an end, but because we do not, it doesn't matter which one is the beginning, we call it endpoints, okay? We name it segment by the two endpoints. For example, in this case is segment AB. Notice the first one, if you're gonna name a line, it has double arrows. If you're gonna name a segment, notice I do not put arrows on that little line that I put above the letters, okay? So I'm gonna name this segment AB, or line segment BA. Either way, it does not matter the order of the two endpoints. You could name the segment by those two endpoints, okay? Well, how about array? Array is part of a line and consists of one endpoint and all of the points on the line in one direction. So array has direction. It goes in one direction. Name array by its endpoint and another point on the array. The endpoint must come first. That is important. The endpoint right here, that comes first. So this one is array AB. You cannot name this array BA because you would be naming another array. Because array has one endpoint, and the endpoint is where the array begins, and then it goes through B. And it keeps going that way. If it would have another point, let's say this point right here, and we could name this C, ray AC would be the same as ray AB. It would be the exact same, okay? So let's say this is AB, ray AB, it would be the same thing as ray AC, because the most important is where does it begin. The other point, just tell me in which direction is it going. So B and C is in the same direction, therefore ray AB or ray AC, we're referring to the same ray, okay? Okay, continuing with rays, we have opposite rays. Opposite rays are two rays that share an endpoint and form a line, okay? They start at the same point and continue in opposite directions. Let's take a look at this. To look at the opposite rays, it would be ray CA. Notice it starts at C and it goes in that direction. And then ray CB. These are opposite rays because one goes, they both start at C and they go in opposite directions, forming a line. Those are called opposite rays. Okay, never make these mistakes. A lot of students make these mistakes. They say, well, ray CA goes to the left, so I'm gonna draw the arrows like that, CA. That is wrong. That is wrong. The arrow always goes from left to right because we read from left to right. The ones that denote where it begins is the point. We notice that it starts at point C and then it goes through A. So this tells us which direction it's going. So there is no need for you to draw the arrow pointing the way the left or to the right. It's always to the right. Okay? And they give us a few examples here in your paper. It says name the 3 line segments. Well, let's see. We got one right here that goes from D to E. So I could put D, E, that's my first line segment. Notice line segments do not have arrows on top. Then we have ray EF. Ray EF goes from E to F or from F to E. That's the other segment. So we have this short one right here. We have this longer one and then the big one, DF. DF. And those are my 3 segments here. And says name 4 rays. Well, let's name 4 rays. Well, the first one would be ray DF. Let's look at that one. Ray DF. It starts at D. It goes through F and through E. So the ray DE and ray DF would be the exact same ray. It says name 4 rays. If I would write now ray DE would still be the same, right? So now I could go to the opposite and says, well, ray FD. ray FD. Notice ray FD starts at F and it goes in the direction of D and it keeps going past D forever. It's infinite. Okay, the other two rays are the opposite rays, which will be ED and EF. So ray ED and ray EF. And those are the opposite rays, which answers this question. Which rays are opposite rays? We already answered it. It's ray ED and ray EF. And that would take care of that question right there. Okay, let's discuss the postulates and we're done for the lesson. Okay, a postulate is a statement which is accepted as true without the need of proving it. Also known as an axiom. Also known as an axiom. The first postulate that we're going to study is through any 2 points there is exactly one line. If you have 2 points, the only thing that you could put through there is one line. Through any 2 points, there is exactly one line, okay? So that is the first postulate. Another one is postulate 1.2. If 2 lines intersect, they intersect in exactly 1 point. See, they intersect at 1 point. That's in geometry, right? They intersect in exactly 1 point. Remember these because you will be tested on them, okay? You need to know this. These are the basics for the whole year understanding geometry. If 2 distinct planes intersect, the 2 planes intersect, remember, even though it has edges in here because we cannot draw infinite, remember the planes go on forever. Therefore, their intersection will go on forever. So if 2 distinct planes intersect, they intersect in exactly one line. That is important. So notice plane R and plane W, they intersect at line ST. And this line goes on forever. And then we have another one here, postulate 1.4. Through any 3 non-collinear points, there is exactly one plane. That's why we use 3 non-collinear points to name the plane. Through any 3 non-collinear points, there is exactly one plane. Notice this time I did not draw parallelogram. I drew a triangles because all you need is 3 points. So I want you to get that clear in your mind. All you need is 3 points that form a triangle, and if you have that, it doesn't matter where the points are, that denotes a plane. So 3 non-collinear points, it does not matter where they are, they denote a plane. For example, in here, look here, are points A, U, and E on the same plane? Some people may think, well, no, they're not. Like I said, if you have 3 points, they're always on a plane. Take a look. What if I draw this diagonal and this diagonal right here? You see that plane that even though it's not drawn, points A, U, and E are on the same plane. Any 3 points are on the same plane. Once the 4th point is the one you have to check whether it is or it is not. All 3 points that are 3 points are always on the same plane. Doesn't matter what. 3 non-collinear points denote a plane. But the 4th point may or may not be coplanar. Okay, so let me erase that and let's go to this question that is here. Let's look. Let me see my eraser if I find it. Let's erase that. And let's look. What is the intersection of plane CUE? So let's look for plane CUE, and I'm going to highlight it so we could see it better. CU and E is this bottom floor. See? It's this bottom right here. That's plane CU and E. Okay, so now, because notice C, U, and E denotes this plane right here. Now, the other plane is plane EBT. Let's use another color. EBT denotes this side wall, right? This side wall right here. Now notice the intersection of 2 planes, like I said, is always what? It's always a line. It's always a line. So what is the intersection of plane CUE and plane EBT? Well, it would be this line right here. Look. See that? And it will keep going forever that way, and it will keep going forever that way. So you would have to answer, it is line, and notice how I denoted EB. Line EB is the intersection of plane CUE and plane EBT. Remember, it is always a line. Do not answer as being segment EB because it would be wrong. Okay? And that finishes the lesson for today for the undefined and defined terms of geometry. Remember to study your vocabulary and work your practice exercises to solidify the knowledge that you learned. And it is better if you do it right now. So don't wait. So see you soon.